So yeah, today's lecture is mostly just going to be practice problems that kind of enforce what we learned this past lecture. So a lot of what we learned was preferences, and so we're going to get a good understanding with respect to the problems that we'll be seeing in tests. How we can kind of relate the preferences that we learned about to a budget constraint, and then there's probably going to be some more stuff that we are able to cover. So I want to revisit extra problem set 2 because when I introduced it last week, there were still a lot of unknowns. So I just want to make sure that we can kind of hammer through that and go at a nice, reasonable pace because I think that now it should be sort of easier to comprehend what's going on. And then I'll take you through an old midterm and see how you guys feel about that. So let me, actually, I won't quite share my screen simply because of the fact that when I share my screen, it makes my self really small, and so you can't see the work that I'm doing. But what I want you guys to do right now is take some time, pull up extra problem set 2, and then we're just gonna breeze through these answers. And hopefully, if you guys have any questions, feel free to stop me. I really do encourage that. It gets more participation. And if you have a question about something, it's likely that somebody else also has that same exact question. So I think that's going to be a good way of going about it. We might do an introduction to extra problem set 3, although I would like to pull up a practice midterm and kind of test you guys to see how far we are along. But yeah, so hopefully you guys have extra problem set 2 pulled up already. I'm going to kind of breeze through these answers. And yeah, so extra problem set 2. Let's go over question 1 real quick. This was one of the questions that I talked about last Wednesday, but because of the limited amount of knowledge that we had, I'm not sure how much of it stuck with you guys. But we're given that this individual has preferences over left shoes and right shoes, right? So that tells us immediately that left shoes, right shoes is automatically going to be a minimum function, right? So referring to perfect complements. And so when we're talking about left shoes and right shoes, we know that there's going to be a 1-to-1 ratio in the way that we're going to consume them. So it'll be 1, 1. This will be a point, and then this will be the L shape that comes through it, right? This is 2, 2, and here's another L point, right? A kink, right? And so here is 3, 3, and so we are right over here. And so at the point 3, 2, right? When we're at the point 3, 2, that means that we're currently right over here, right? And so if you kind of think about what is their marginal rate of substitution at the point 3, 2, there's 2 ways that you can approach this. You could break it down into MRS equals marginal utility of, this is x1, x2, right? Marginal utility of x1 over the marginal utility of x2. Or you can simply just kind of look at the slope and think about, well, what is this? So I'll give you guys a quick 2 seconds. You guys can use either approach. But when you have an answer, feel free to just leave it in the chat and let me know what you guys think. What is my MRS equal to at this point 3, 2? Oops, sorry. All right, so I'm seeing the answer 0 come up. Does everybody agree with that? Yeah, 0. All right. So we seem to be in agreement that the MRS is 0, right? And so you guys can clearly see that the slope is 0, right? So that is a dead giveaway. But if you think about it in terms of it mathematically, right? If my utility is equal to the min of x1 comma x2, right? And I'm currently at 3 and 2, so I'm currently at min 3, 2, right? The marginal utility of 1 unit of good 1 would put us at the min of 4, 2, right? And so you notice that in both cases, the utility stays the same, which tells us that the marginal utility is just going to be equal to 0. And so you really don't even need to know what the bottom is because of the fact that the numerator is 0. I guess there's cases in which if the denominator is 0, and you'll see this if we were like here, for example, this would be a case in which the denominator was 0. And so that's when we get those undefineds, right? So when you're working with these perfect complements, you're either going to have an MRS of 0 or an MRS that's undefined, okay? So that was kind of a refresher. Hopefully you guys feel good about that. Now let's go back over question 2, right? So we're just, as I mentioned before, just breezing through this. Looking at question 2, we're given the fact that P1 is equal to 6, P2 is equal to 3, and M is equal to 24, right? And so he comes back to the market, or he comes back from the market, and x1 prime is equal to 3, and x2 prime is equal to 2, okay? And you offer him, so offer 3x1 or 1x2, okay? Oh, whoops, 3x2 or 1x1. I apologize, guys. And so how do we know whether he'll be willing to accept this offer or not, right? So I want you guys to kind of think through the steps. I'm going to draw it on the board, and in 30 seconds-ish, we're going to kind of reconsolidate and see whether we have the same kind of work. All right? Oops. Okay. Okay, all right. So hopefully that was enough time to kind of think through this problem. Now I'm gonna go over the answer and see how you guys kind of feel about the answer. Yeah. So Becky, you're correct. I messed up the MRS. I just wasn't thinking straight. It's just P2 over P1, right? Um, so in this situation, right, we we're given the fact that we've come back with an optimal bundle. And so when we have an optimal point, right, that tells us that the MRS is equal to the price ratio, right, which is just this slope, which is just going to be -2, right, or 2 in absolute value. And so that tells us that P1, oh, sorry, it's P1 over P2. Yes. Sorry about that again. Just keep catching my mistakes. It's P1 over P2, which is 6 over 3, which is 2 over 1. That's correct. And so when we know what our MRS is, right, that's essentially telling us what our ratios of marginal utilities is. And so when you break it down, and so this should also be 2 over 1. So 2 over 1. I apologize for kind of the mistakes, but kind of the logic there remains the same, right? So our MRS is 2 over 1, which means that for every additional unit of good 1 that we have right here, that's going to provide 2 additional utility, right? And so for every 1 unit of x2 that we add, that'll provide 1 unit of utility, right? And that's kind of just the ratio of it, you know? And so it's basically 2 utility for every 1 utility. That's kind of how you want to word it. And so going through, right, with this kind of thinking, we know that if I were to offer this person 3 units of good 2, right, that'll provide them with 3 times 1 equals 3 utility. So they would get 3 utility. Now they would have to give up 1x1, so they would be decreasing with 2 utility. But the net effect of this trade is that they're up 1 utility. Yeah, so J Caesar, the price ratio at the optimal point is equal to the ratios of the marginal utilities, which is just our MRS, right? So basically, from what we've discovered is that given the marginal utilities this person has for each good, right, it would be beneficial to make this trade because they'd be getting 3 utility and only have to give up 2 utility. So aside from kind of the brain farts of my price ratio, hopefully the steps make sense throughout, and you guys are able to get this answer as well. Okay.
I have a question.
Yeah, what's up?
So if the MRS is 2, could you say that you would trade 2x2 for 1x1?
Yeah, exactly. And you would do it for like 6 and 3, basically just any ratio that's 1 to 2, right?
Okay, thank you.
Yeah, that's a good question. Okay. So I'm gonna skip number 3 because number 3 was pretty straightforward and we had talked about it in the last lecture, and I think that kind of made more sense at the time. So we're gonna skip 3. Let me look at 4 real quick and see whether we should do 4. But yeah, today is just gonna be a bunch of practice problems. So hopefully you guys get ready. Number 4, I think, is pretty straightforward. I don't think I need to do this on the board, but I can kind of just walk you guys through it, right? Essentially, because of the fact that there's a negative sign attached to each good, that tells us that they're going to provide negative marginal utility, right? So if you were to take the partial derivatives, which is what marginal utility is, they would be negative, which tells us that adding goods actually brings down our utility. And so we definitely don't want to bring down our utility. So we want to consume as little as possible of each good, which just happens to be 0, 0, because we can't consume negative amounts, right? So yeah, hopefully that is pretty straightforward. Here's a question that we can do. So looking at number 5, we're given the information u is equal to x1 to the 1/2, x2. And the question is, holding x1 constant, would an increase in my consumption of x2 raise or lower my marginal utility of x1, right? So the way that we can kind of think about this is that we can look at our marginal utility of x1, and if there's an x2 term, if we raise it, we want to see how that affects the marginal utility function, right? So marginal utility of x1, and this is just a good practice for derivatives, is 1/2 x1 to the negative 1/2 x2, right? And this is all equal to x2 over 2x1 to the 1/2, right? And so you guys can see that as x2 increases, the marginal utility of x1 also increases, right? Because we have x2 here in our numerator. So yeah, hopefully you guys can see that. That's just kind of a quick question, and it really is only a test of being able to take partial derivatives. But that's essentially what they're asking for that's essentially what they're asking for in this question. Okay. I got requested to do 3C. Would you guys want to see that? Maybe just leave like a quick yes or no. Okay. I actually don't remember what 3C is. So let's go to 3C. All right, so this is the apples and bananas question. So 3C. And you basically want to show that I prefer 2 apples to 3 bananas, right? And in this situation, when you prefer 2 apples to 3 bananas, you can kind of think about it. I think that the easiest way to think about it is in terms of a perfect substitute equation, where it's like you either have 2 apples or you have 3 bananas, and you want to see which is better. Because remember, with a Cobb-Douglas equation, you're always going to have positive values of each good, or else your utility is 0. And so in this scenario, perfect substitutes make the most sense because you're going to be consuming on the margins, right? If you remember, which means you'll have either all apples or all bananas, right? So what I'm trying to say is your utility function should look something like a perfect substitutes. So I think that just the easiest one that you can kind of think of is 2a plus b, right? So essentially what this utility function says is that apples I view as being twice as good as bananas in terms of utility, how much utility they bring me, right? And so if there's no price indication about how much each of these fruits are, you're either given 2 apples or you're given 3 bananas. You're going to be able to plug these numbers in, right, to our variables, right? So all apples equals 2 times 2 equals 4, and all bananas, and that's not spelled that way, all bananas equals 3 times 1 equals 3. And obviously, right, you would rather have 4 bananas or 4 utility to 3 utility. This isn't the only equation that would work. You can do any combination in which apples are twice as favorited as bananas. You could even do something like 5 and 3, right? As long as having all apples is better than having all bananas, that would work. Hopefully does that answer your question? Okay, hopefully it did. So the extra problem sets are on your Gaucho space. They're in the like problem sets. They're right underneath the like actual homework that you guys are given. And these are kind of just, they're quick questions that you can get out of the way early. But you know, I think they're good practice for sure. So moving on from there, let's go to problem 6, where we're given that the bundle 6-1 is preferred to 1-6. And so they're asking which perfect complements utility function is consistent with this preference. So immediately, right? Immediately we can eliminate all of the answer choices that don't have a min function, right? So A and C right away can just be eliminated. And so we're left between the options min of 2x and y, or the min of x and 2y, okay? And I guess the none of the above is an option. Just kind of a disclaimer about none of the above is that Hartman is not afraid to use none of the above as the answer choice. So if you feel confident about your answer and the answer is none of the above, I wouldn't be scared to select that. But that's kind of just a tangent. I think that the easiest way to approach this is to just plug in the numbers and see which one's preferred, right? So with this min function, say I plug in 6, 1, what I would get is 12, 1, right? And the requirement is that this is preferred to the min of 2 and 6, right? Well, we know that the min in this case is going to pull out, so this is going to pull out 1, and this is going to pull out 2, right? And so basically what you can see is that this answer choice doesn't make sense because this bundle is preferred to this bundle with this utility function, okay? Now, on the other hand, we want to see whether this is a valid choice. You know, if it's not, then the answer would be none of the above, right? So min, plugging in 6 and 1 into our values of x and y is going to yield 6 and 2. And we want to see that this is better than 1 and 6 being plugged into here, right? Where this is 1 and this is 12. And we'll see that this is going to yield 2 and this is going to yield 1. And so this answer choice, it follows through with what the assumptions were beforehand, right? So this is going to be the answer choice where your answer is going to be D, right? Are there any questions about this one in particular? I think working with like perfect complements and perfect substitutes can always get a little tricky, but I just recommend just plugging straight in for both bundles and seeing. Yeah.
The 1 and 2 on the bottom.
So to answer the question, Kyle, we know that we can only look at the min functions because it says which perfect complement utility function reveals these preferences. And so if you remember, the perfect complements always have the min function attached, whereas perfect substitutes, which were the other option choices, have like the adding of constants. So x plus y, this is something that would be perfect substitutes, for example, right? Where you're either going to have all of x or all of y, right? So there you go. I'm going to move on to question 7.
Oh, wait. So going back to what Victor was saying, why did you have a 2 and a 1?
Why did I have a 2 and a 1?
Yeah, for like, because you said that one would yield 2 and the other one would yield 1.
Oh, because so just looking at answer choice D, right? So
okay.
Let's look at min. This is x, this is 2y, right? And I plug in 6 and 1. So I plug in the first bundle. So 6, 1 goes to 6, 2, right? Just multiplying or just plugging in each of these for our variables. And so if it's the min, right, I'm choosing the smallest number between the two, and that's my utility.
Okay.
Right, so my utility is 2 in this case, and it would have been 1 in the other case with 1 and 12.
But you want the
You want the higher utility
higher one.
between the two,
Okay.
which is 2
Oh.
versus 1.
Does
that make sense?
Yeah. Okay. Thank you.
So the smaller number of the ordered pair is the utility from it?
Yeah, that's like the whole kind of thinking about utility is because right, going back to left shoe, right shoe, if you have 1 right shoe and you have 12 left shoes, your utility is only going to be 1 because you can make 1 pair between them.
And so that's why the first pair didn't, or that first equation that was given to us, that one doesn't work because it would have been 1 and 1.
No, well, it would have said that 1 was preferred to 2. So it would have said that. So the reason that answer choice B doesn't work is because if you kind of just plug it in into your head, right? If you plug in the bundle that he's supposed to prefer, that produces a utility of 1, whereas the bundle that he prefers least actually provides a utility of 2. So
that doesn't make sense.
Which is inconsistent, right?
Yeah.
Yeah. Okay, good questions, guys. Hopefully these are kind of making more sense as we like ask about it and we like get a better opportunity to think through these. So let's look at question 7. And we're looking at marginal utility with respect to chicken. So the marginal utility of chicken at the point 8, 4, right? And so 8, 4 really just means that that's going to be where what we're plugging in, right? So we first have to look at utility, and utility is equal to 6r squared plus c. And so if I take the marginal utility with respect to chicken, right, I'm just going to get 1, right? And so you notice how my marginal utility is only 1, right? And there's no variables that are in there. So when your marginal utility ends up being a constant, that's going to tell you that at whatever levels, whatever bundles you have, right? So it doesn't matter what's in these like R and C. So R comma C, whatever your bundle is, your marginal utility for chicken is always going to be 1, no matter whether you have 1,000 units of chicken or 0 units of chicken. It's always going to be 1. Okay, and that's because of the fact that the marginal utility was just a constant. Does that make sense?
So whenever we're talking about marginal utility with respect to like a certain amount, it's always going to be 1.
Only if the marginal utility is 1. So let's say, for example, I had taken the marginal utility of rice. Okay. So R and C, R is rice, C is chicken, at 8, 4, right? I would have gotten so 12R. And so in this case, I would plug in 8 into my R, right? So I would get 96. Okay. Now, depending on what your values for R are, right? So say R is 0, then your marginal utility is 0. But say that R is 1, now your marginal utility is 12, and so on and so forth, right? Okay. So it really just depends on what you spit out for your marginal utility, right? And whether it has variables within the marginal utility function.
Okay.
Every time you get another chicken, your utility is gonna go up by 1?
Yeah. Basically, any single increase in chicken is always going to yield 1 more utility.
Oh, okay.
So if I go from 12 to 13 units of chicken, I'm gaining 1 utility. If I go from 1,000 to 1,001 units of chicken, I'm gaining 1 utility.
And you classify it as a type of good then? Is there like a name for goods like that?
No, I don't think so. No.
Okay.
Yeah. Are there any other questions about this? Like the concept of marginal utility is something that I think is so important. I really want you guys to be familiar with.
Just to clarify, so you just essentially just took the derivative of C and got 1, and that's why it's 1.
Yeah, so
just to like,
because I'm taking the marginal utility of C, I treat my R as a constant.
The constant. Okay.
And so, the derivative of a constant is just 0. And the derivative of c is just 1, right?
Okay. Okay. Yeah. Okay. I just was confused about that for a minute. Okay. Got it.
So in
Okay.
this case, your utility is only going to go up if you get more of rice, then, right?
Well, no, it's
If-
still going up with chicken,
Mhm.
but it's going up by a constant amount. So basically, increasing my consumption of chicken is going to increase my utility by 1,
Okay.
right? So let's say that I'm at 8 and 4 right now. So I'm currently at 8 and 4. So it'd be 6 times 64. I don't know what that is off the top of my head. So 6 times 64 is equal to 384 plus 4. So 384 plus 4 equals 388, right? So having this bundle, 8, 4, is going to give me 388 units of utility, right? So looking at the marginal utility of chicken, that's saying I'm holding my consumption of rice constant, and I'm increasing my consumption of chicken by 1, right? So I'm going to go from 8, 4. I'm going to go from 8, 4 to 8, 5, right? And that tells us what the marginal utility of chicken is, right? And so I go from 384 plus 4 to 384 plus 5, which is equal to 389. So my utility only went up by 1 as I increased my consumption of chicken by 1. And it doesn't matter what you have, right? If I went from 8.5 to 8.6, then I would get 390, right? Do you kind of see the pattern that's going on there? Right?
Yeah.
Okay.
So the
Alright.
answer for the marginal utility is 1 or 388?
The marginal utility is 1.
That's what I thought. Thanks.
The marginal utility of one of chicken is just 1, right? But in
Yeah.
total, it's 388 at that point, 84.
Yeah, so the marginal utility of chicken is 1. The total utility is you just plug in these two values into your utility function. Okay. All right.
So when you found chicken, do you always plug in that X to find out what it is, like how you got 96?
Yeah. So wait, for chicken or for what?
Whatever 12R is.
So 12R, this is the marginal utility of rice.
Oh, rice. Okay.
Rice.
So then you would always plug in your, which one was rice, Y or X?
You would always plug in. So if you're finding the marginal utility of chicken, is this what we're still asking about?
No, he means rice.
Rice.
If you would plug in that 8 on that 12R, because that's the marginal utility of rice, and rice is X.
Yeah, so
it takes 96.
if I go from, that's a good question. If I was at 8 units of rice, right, then that means that my marginal utility of rice is 12 times R, and then you plug in your 8 units, and that's 96. So you would get 96 additional units of utility from that single increase of rice. Does that make sense?
Yeah.
Okay. Yeah. But see how this is flexible? So basically the higher amounts of rice that I have, the more my marginal utility is going to be, right? So say that I had 10 units of rice, then my marginal utility of rice is 12 times 10, which is 120. So now I'm getting 120 units from an additional increase in rice. Does that make sense, guys?
So the marginal utility, that's going to be relative to that point, though, right?
It's relative to that point, right? Exactly. So the marginal utility is going to be relative to a point, right? When you have a variable inside your marginal utility function, right? So the only reason that this is constantly at 1 is because you notice that there's no C term in here, right? It's only 1. Okay.
So the marginal utility would just be 96. It wouldn't be 12R. It would just be 96.
It would be 96, right? But That's only at this single point right here.
Yeah. Okay. Thank you.
Okay.
Okay, so for part B, how would you define marginal utility?
Marginal utility is, so I think of marginal utility as being the increase in utility when you increase a good by 1 unit, holding the other good constant. So if I'm talking about the marginal utility of x1, then the marginal utility of x1 is the increase in utility by having 1 more unit of x1 while holding my consumption of x2 constant. And so the marginal utility of chicken, right, was the increase in my utility going from 388 to 389 by increasing my level of chicken by 1, going from 4 to 5, while holding my consumption of rice constant, 8 and 8. You see that?
That makes sense.
Okay. All right. I'm glad that you guys are asking questions and feel comfortable. I know that it's kind of hard over Zoom. You maybe
So-
don't want to ask questions.
If marginal utility describes the indifference curve, right?
So the ratio of marginal utilities describes the indifference curve. Yeah.
Right. So in this case, the ratio would be, if we take the marginal utility of both of them, it would be 12R over 1, right?
So yeah.
So it's just 12R. So if we were to be given, if we were to sacrifice 1 item of chicken, we would need 12 items of rice to stay on the indifference curve, right?
So that depends on how much rice you already have, right? Because it depends on where you are along the along your consumption of rice. And so
at that point,
notice that this isn't Cobb Douglas, right? So you're not going to have that nice downward sloping indifference curve, right? So your optimization is going to look different because you're not going to have DMRS in this case. So you're going to be consuming at a point, is what I'm trying to say.
right. This utility curve describes a perfect substitute, right? Because we're adding two things.
It's not perfect substitutes because of the fact that your R is squared, right? Perfect substitutes are for constant terms, right? Where the exponent of R and C are both 1.
Oh, okay.
So there's no description for what this is. Not like a given term that we've assigned. Okay.
The MRS for this would be that would be 96 over 1 then, right?
It'd be 12R. So your MRS would be it would be 96, yeah.
Okay, cool. At that specific point.
At this specific point, right? So remember, yeah. MRS is just the slope of the indifference curve at a given point.
Mm-hmm. Thank you.
Okay. So does that kind of answer your question, or am I able to move on?
Yeah. Yes.
Okay. All right. So okay. Number 8. I'm not gonna draw. Well, actually, I will draw it out. Number 8 is a person that gets more utility from cherries but gets no utility from yogurt, where yogurt is on the horizontal axis and cherries are on the vertical axis, right? So we're here, yogurt and cherries, and we're saying that we're indifferent about cherries, or actually no, we're indifferent about yogurt, but we really enjoy cherries, right? And so how do we graph this on like a XY intercept kind of graph, right?
They're just horizontal lines going up, right?
Yes, exactly. So remember how, and this will depend on whichever good is the neutral, right? So technically yogurt is a neutral. It depends on whichever good is the neutral, right? Whether it's on the x-axis or the y-axis, right? It just so happens that the neutral is on the x-axis right here. And so that's why we have these horizontal lines. But if it were flipped, we would have vertical lines, okay? But pretty much, I guess a rule of thumb is that the vertical line or the lines are always going to be parallel to the good that's in neutral, right? So in this case, y is the good that's neutral, and so these lines are parallel to this axis, right? Going up towards the good, right? Whereas if I had, I'm just going to draw this a little smaller. If I had something like this, then these would be my indifference curves, and we would be going that way. All right. Okay. I think that's it for this one. Hopefully this one was a little bit easier. And I can't imagine you'll be asked to draw indifference curves because I think it's multiple choice. So let's look at question 9. Bob's utility is given by, so Bob is given by x1 to the 1/3, x2 to the 1/4. John is given by x1 to the 1/3. Basically, it looks like the same thing. x2 to the 1/4 plus 100. This is a 7. And I think there's one more person. Sam is equal to natural log x1 plus x2 squared. And so this looks like a really nasty problem just because of like what's given, but let's read what the question is. So circle all correct statements. Assume an interior solution where x1 and x2 are both positive amounts. So let's take a look at what we have right here. So we have to make basically distinctions between what A, B, C, D, and E are even asking us, right? So first, we want to make an analysis between the distinction between each of their indifference curves. So, or I guess their MRSs, if you will. So I think that what you guys are able to do right here is, and this kind of takes like a little bit of training, or not training, but just more practice at seeing the differences, right? So this is something that I noticed as I was writing it down, is that Bob and John have very similar indifference curves, or utility functions. Sorry, I keep saying that. They have very similar utility functions. It's just that John has 100 added and is raised to the 7th. But if you guys remember what you've been taught about monotonicity, is that monotonicity doesn't make a distinction between preferences, right? Monotonicity holds preferences constant, right? And so what you see right here is essentially a monotonic transformation where we've added a number. It doesn't matter what number we add, but we've added a number and we've raised by an odd integer, right? Hopefully you guys can see that. It's a little bit tricky to kind of think about, but essentially what's going to happen is that if we were to find the MRS of Bob and John, the MRS of Bob is equal to the MRS of John, right? Which means that if they're at the same points, right, or essentially if they're facing the same exact prices, which we assume that they are, they're going to have the same exact point, right? So let's kind of take a look at the answers. Bob's MRS is bigger than John's. Well, we kind of just described the fact that they are equal to each other, right? So that can't be right. Sam's MRS is 0. Let's take a look at his MRS. So marginal utility of good 1 is, so MRS of Sam MRS of Sam is equal to 1 over x1, and MRS of good, or marginal utility of good 2 is equal to 2x2, right? And so what you can do right here is multiply through by 2x2. So this can be simplified out to 2x2 over x1, right? And what you'll notice is that Sam's MRS is never going to be 0 when x1 and x2 are greater than 0, which is given in the problem. Okay, so A and B are incorrect. C looks like what we just established, so let's keep C in mind. John's MRS is infinite. Well, let's take a look at John's MRS, which is the same as Bob's MRS. So I don't want to, I'm going to use this one. So C 1/4 x2 over 1/3 x1. And I'm going to multiply through by 12. So I'll get 3x2 over 4x1. Okay. And so you're never going to get a point in which John's MRS is infinite, right? So that's kind of making an assumption that John and Bob have the same MRS, but I assure you that if we were to find the MRS of John, it would be this same exact thing, right? So, oh, actually, this is 1/3. Whoops, I just flipped them. This is 1/3 over 1/4, so it should be 4 over 3, right? But you're never going to have x1 be 0 in the denominator, right? Which would imply that John's MRS is infinite. And Sam's MRS, we've already found, is different than Bob's, right? Which is this one right here. And so the only possible answer choice is C. And that's kind of like a messy way of approaching this question, but I think it's the best way of just kind of going through each of the answer choices and kind of analyzing which ones are correct and which ones aren't. So
when would the 7th power be relevant to the problem?
So the 7th, so the reason 7 comes in is because it's an odd integer, right? And so we know that when we raise by an odd integer, we're always going to keep the same sign that we started off with. So if we raise a negative number by an odd integer, we're going to end up with a negative number. And so that keeps our preferences the same, right? In terms of it being a monotonic transformation. Does that make sense?
Yeah, so we don't really need to focus on that for the MRS.
So yeah, because the MRS, right, if you think about it, is really just a ratio. And so the ratio, we're going to have 7 attached, so it won't look exactly like 4x2 over 3x1. But when we when we do figure it out, right, it will be a 4:3 ratio, right? It may be something like 28 over 21 or something of that nature. But at the heart of it, it will be a 4:3 ratio, right? Because of the fact that a monotonic transformation doesn't change the MRS.
Yeah, so those,
okay, so because 100 and the 7 are monotonic transformation, we could just assume it has the same value as x1 to the 1/3 and then x2 to the 1/4.
Can you say that again?
So because it's a monotonic transformation, we can assume that it has the same value as x1 to the 1/3 and then x2 to the 1/4.
Yeah.
Okay, thank you.
Yeah, because that 7 is going to cancel out when we take the ratio of the
right?
marginal utilities.
So the 7 is going to be present in both the numerator and the denominator when I take the marginal utilities. And so they're just going to get canceled out, right, when we find that ratio. There's a question from Raj about the MRS for Sam. So let's kind of go through this. The marginal utility of good 1 is the derivative of the natural log, which is just 1 over x1. right?
I
We're
think
good
you
with
mean
that.
just like it would be on the bottom, right? Just by like dividing by the fraction.
So that's a good question, right? We want to keep this in the numerator first, and then we'll kind of analyze everything once we have it all together, right? So we have 1 over x1. This is the marginal utility of good 1 right here. And we want to find the marginal utility of good 2, right? So we eliminate this, and then this just becomes 2x2, right? Is everybody good with this so far? So we have, this is the marginal utility of good 1. This is the marginal utility of good 2, right? Right? Everybody feel good about that?
Yeah.
So
Yeah.
basically, when I have something like this, right, I can multiply through by 2x2 over 2x2. And this is completely legal because of the fact that this is really just 1, right? We're basically just multiplying by 1. And so this, right, when we rearrange this, you can kind of think about this as being 1 times 2x2 divided by x1 over 2x2 times 2x2, right? The ordering is kind of still the same, right? But it makes it easier to visualize why we're able to do what we just did. So now this is going to cancel with this, right? And we're going to be left with 2x2 over x1. Do you guys see that?
No.
I'm still confused on how you. I'm
And
still
yes,
confused
you
on
and
how
I will.
2x2 goes to the numerator, not the denominator.
Because when you have 1 over x1 and then divided by 2x2, wouldn't you just multiply by the reciprocal to get it out of the denominator? Like you would multiply by 1 over 2x2. So it'd be 1x1 or 1 over x1 2x2.
I see what you guys are saying. You divide by that. So you say it should be 1 times x1, 2x2. I know that's like a math rule, but I also know that what I just did is completely legal.
Yeah, because if you take the, it's like you're multiplying the reciprocal of 2x, 2x2, and that's pretty much you're flipping it, because you could take that MRS, the 1 over x1 over 2x2, as saying 1 over x1 and then 1 over x2. So if you flip that, you get 2 on the top. So the bottom portion, that the marginal utility for the second one, for x squared, it's actually, you turn it into 1 over 2x2. So if you multiply that out according to the rules, the 2x2 goes to the top.
Yeah.
The 2x2 is just
if you guys have
2x2
more
over
questions
1.
about this, I would definitely show it to a TA, but just looking at it, I think is, I mean, I can't, I mean, this looks right. So if you have questions about it, definitely show it to a TA. And if a TA says that that's right, whatever they do is right, then, you know, they'll obviously follow them. So this is the MRS of Bob. To answer Mark's question, this was just this. This is the MRS of this, right? Put it here. So I can understand how there's questions about the MRS of John, and so I'll just go over that real quick. Okay. But as for the MRS of Sam, definitely have that checked out. So yeah. Let's look at MRS of John solely. And then I kind of got to wrap up real quick because I have drop in at 2. So let's look at John. John was given by x1 to the 1/3, x2 to the 1/4, plus 100 raised 7. So something like this. So we want to find the marginal utility of good 1 over the marginal utility of good 2. Okay. So just a kind of disclosure, this will get kind of messy because of like chain rule and stuff, but I'm going to try my best. So marginal utility of good 1 is going to be 7 times x1 to the 1/3, x2 to the 1/4 plus 100. And then when I take the derivative with respect to x1, right, because of chain rule, this will be equal to 1/3 x1 to the negative 2/3 x2 to the 1/4. And then because 100 is just a constant, that'll just get dropped. Okay? Now, finding the marginal utility of good 2 will be similar, right? And then we get 7 times x1 to the 1/3, x2 to the 1/4 plus 100 times, now we're doing the marginal utility with respect to good 2. It'll be 1/4 x2, or x, let's just keep it in order. So 1/4 x1 to the 1/3. Now x2 to the negative 3/4, right? Because I have these like terms, and I'm going to show this in a different color. Because I have these like terms right here on both the numerator and the denominator, I'm just going to cancel that out so that I can work with something that looks cleaner. And so now I have 1/3. I want to bring this x1 down to the bottom, and I want to bring this x2 back up to the top. I have 1/3 x2 over 1/4 x1, which is just going to be equal to 4x2 over 3x1. So,
So when you put 7 as the coefficient, why didn't you raise it to the 6th power doing the chain rule?
oh,
Oh,
I guess I
okay.
should have.
Sure.
But it still is the same where it cancels out.
Yeah, exactly. Okay.
Okay, hopefully that answers your guys' questions. I do have to go because I have drop-in like starting now. But thanks guys for showing up. If you have any questions, feel free to remember ask a TA about the algebra of it. And then this will get
Thank you.
posted. So yeah. All right, have a nice day, guys.